Good morning, all. I'm Sangeetha, working as assistant professor in the Department of IT, Tech Multitech, Dr. Rangarajan, Dr. Shagundala Engineering College. Today, we are going to see the topic process in the operating system from the Unit 2. The subject code is 231AI423, and this is 23 curriculum, autonomous syllabus. So today, we are going to see about this process topic. What is meant by process in the operating system? Process is program in execution that undergoes a number of states in its lifetime. So each of this state, a process undergoes certain operation that enable the process to execute into completion. So states of the process here listed below. First one is new process, next one is ready, next one is running and waiting, terminated. So at the new state, the process is created. In the ready state, the process is ready with all its resource allocation and waiting for CPU allocation. Next, running state. Running state, instruction in the process are being executed in the CPU. In the waiting state, process is waiting for completion of any input or output or any other event to occur. Next, fifth one is and last stage is terminated state. Process finishes execution and exits the system. These are all the 5 different states of the process. So we can show in the diagram too. The process states are depicted in the diagram. Here the new states, ready state, running, terminated, waiting or blocked. So new state, the process is here created and is admitted to ready state. So if the process is created, it is ready to admitted state, admitted into ready state, and it's ready for execution now. So after admitted into ready state, it's go under running state. So if the process is running, after some particular time, the interrupt will occur. Any of the interrupt system interrupt will occur. So in the interrupt, any other higher process will come for execution, or this running process will need any of the input output resources or any other event to occur. So the running process will go to waiting or block state, and then after completing its input output event or any of the resources it uses and completion of the IO, it will the waiting process is again admitted to ready state. If the running process finishes all of its execution, it's again go to the terminated state. That is, the process completes all its execution with the resources and all it with input and output event or any other event. It will exit the process state. Okay. So this is again the terminated state will occur. So this is the process states depicted diagram. So you clearly understand this diagram. With the help of this diagram, you can able to see the process of the states. Next one, we can see in detail about this process state. So different process operation in operating system, it will transit from one state to another. First one is process creation, and next one is process dispatch, and next one is process preemption. Next, process blocking, process termination. So first one is process creation. So here the first operation it undergoes when its entire system is process creation. So it involves a formation of a process and is associated with the new state. So whenever a process is created, that is the new state of the process. Occurs due to any of the following events. If the process is created, this creation of the process will occur due to any of the event. First one is system initialization. When the computer is started, a number of system processes and background processes are created. Okay, so if first circumstance system initialization, and second one is user request. That is, user may start executing a program leading to creation of a process. If the particular person start executing a Java or C program, he is leading to a creation of the process. Next, child process system call. This one of the circumstance. A running process may create a child process by process creation system call. Batch system. The batch system may initiate batch jobs. So particularly it will initiate a batch set of jobs. So process may be created by another process using fork. In the first unit, we have seen a fork and exit both system calls. In fork, we are creating the process, that is child process. That is creating process is called the parent process, and the created process is the child process. The child process can have only one parent, but the parent process may have many children, right? So we that for example we have only one parent, and our parent will have more than one children, right? So that only the process, the parent process is only one, and the child process will be many. Both the parent and child process have the same memory image, open files, and environment strings. However, they have distinct address space. So the address is different, and but it will share the same memory, same files, images, environment strings, everything. It will be same for both parent and child process, but it will have a distinct different address space. Sorry, address that is ID. So a diagram demonstrate process creation using fork. And these are all the circumstances, that is system initialization, user request, child process system call, batch system. These are the circumstances when the process is created. So next we will demonstrate the process creation using fork. So here in this diagram, the parent, when the fork system call is called, fork is called, the parent will create the child process and the execute the process will be executed during execute system call. Next, the parent will wait for until the child executes his process. The parent wait will for a particular some time. Then child process complete the execution, it will exit the process. After that, the waiting parent process will execute and it will complete the execution. This is a process creation using fork. Next, process dispatch. The second state is process dispatch. When the process in the ready state is selected for execution by the scheduler, process dispatch operation occurs. So process dispatch is initiated according to the scheduling algorithm used. It may happen when the CPU become idle and the ready queue as process time quantum allocated for ongoing process expires, higher priority process enter the system, or hardware interrupt occurs. So when a new process is assigned to CPU, its status is loads from its process control block. So process control block is already seen in the first unit. So detailed structure will be given in the first unit for the PCB. Next state is process preemption. Next, the process preemption means the process is interrupted. Process preemption is an operation by which the execution of an ongoing process is suspended and some other process is selected by the CPU for the operation. Okay, for execution. Process preemption may occur when time quantum of an ongoing process expire, a higher priority process enter the ready queue or a hardware interrupt occurs. So whenever the higher priority process enters the CPU and the process time quantum of the process particular, for example, in the scheduling algorithm in the round robin, there will be a time quantum for 2 millisecond or 1 millisecond or 4 millisecond. So for particular period of time, the process will execute in the CPU. If the process and that particular time quantum ends, the process will expire. The CPU will switch from process to this process to another process. For this type of situation, and the higher priority process comes enter the ready queue for the hardware or for the execution or hardware interrupt occurs, this process preemption will occur. The preemption of executing process in the CPU causes a phenomenon called context switch, and this particular thing we called as the context switch. Here the context or state of the outgoing process is stored in the PCB so that it can be reloaded when required and execution can be resumed from the same point at the earlier. Okay, so this process for a particular time quantum for 1 millisecond, it executes the, for example, in the round robin scheduling algorithm, the time quantum is for 2 milliseconds for each process. So many process, nearly 5 to 6 processes are running in the CPU. This 2 millisecond, the particular process executes and it did not completed its execution. So it did not completed its execution. So it will goes to waiting state. Since the CPU switched from this process to another process, after 2 millisecond, it will it will come again to the particular process. So that time the Actually, already waiting state process information is stored in PCB so that it can be reloaded again or resume from the whatever stage it is stopped, and it will resume from that particular state. That's information is stored in the PCB, process control block. This is the process preemption state. The following diagram demonstrates process dispatch and process preemption. First, the process is ready, so it will dispatch to running, and then running process is preempted. That is process preemption. With the higher priority process or any other time quantum ends, the process expires. That situation, the running process will preempt and it will go to ready state. After that, some event occurs or a higher priority process execute ends, other process ends, or it will go to running stage. This is the demonstration of the process dispatch and process preemption. Next stage is process blocking. The ongoing process is blocked. Okay, the ongoing process is blocked and put in the waiting state and swapped out of the CPU if it needs some event to occur in order to proceed with the execution. This event may be input output system call, since I want event or executed in the main memory and don't require the processor. So ongoing process is blocked if any of the IO want to execute. So the IO process is mainly will be executed in the main memory, and it won't require the processor. So that time the process will be blocked and put in the waiting state and swapped out of the CPU, and some of the event to occur in the outside the CPU. After that, it will come again to after complete its event, that is IO event or anything, it will come back to the processor. The scheduler will schedule the CPU, that is the process from the CPU, that is ready state to running, waiting for the running state. Okay, here the operating system blocks the process when the process itself demands so. After the event is complete, process again goes to the ready state. So this is a process blocking. This diagram demonstrates process blocking, that is ready, dispatch, and then it's the process is running, and then preempt state. Then if the process is waiting for any event to occur, it gets blocked. After the completion of IO, it will again go to the ready state. This is the process blocking state. Process termination. This is the last stage. The process termination is the operation of ending a process and releasing all the resources that have been held by the process. The process ceases to exist after its termination. So after the termination of the process, it will exit the CPU. Similar to process creation, there may be multiple reasons for process termination. So if we have seen the process creation circumstance, that is system initialization, user request, and process creation, any of the circumstance, the process is created. Under four condition, if the process is created. For the process termination also, we have some of the multiple reason to follow. For example, the process has completed the execution of its last instruction and it's terminated by the OS itself. First reason is it completed its execution and the OS itself terminate the particular process. This is the first. Second one is the child process can be terminated by its parent process if its task is no longer relevant or needed. The child process sends its status information to the parent process before it terminates. Also, when a parent process is terminated, the child process also terminated, as well as child process cannot run if the parent process are terminated. Okay, so this is a second circumstance. The process can be terminated by the operating system if there are services error. So if any particular service error occur, the process can be terminated by the OS itself. This is the third circumstance. And fourth is the hardware malfunction may also cause process termination in the system. In most cases, the process termination occurs when a process executes to completion. So the steps involved as follows. The parent process issues a SYSTEM message to the child process as a signal to initiate termination. On receiving this signal, the child process performs cleanup procedures like releasing allocated resources, files, giving up access to shared variables and tables, etc. The child process then exit and the control return to either the parent process or the OS. These are the steps for process termination. Next, before that, we have completed the process states. Okay, so already we have seen the process and process states in detail. And next, we are going to see about the threads. Threads. What is meant by threads in OS? Thread is nothing but a single part of execution. Thread is nothing but a single part of execution. Threads in OS are a single sequence stream within a process. So these are also called as a lightweight process. A thread is a flow of execution through process code with its own program counter that keeps track of which instruction to execute next, system register which hold its current working variables, and a stack which contains execution history. So the system will execute the particular process code. That's a lightweight process. Thread is a flow of execution through process code. That is, one program counter will keep track of every instruction to be executed next. The thread shared with its peer threads few information like code segment, data segment, and open files. So thread will share the some of the variables like code segment, data segment, and open files to another threads, that is peer threads. When one thread alters a data segment memory item, all the other threads can see the changes and also able to modify it. Threads are used to achieve parallelism. It divides a process into multiple threads which have independent path of execution while sharing the same memory, space, and resources. For example, tabs of a web browser, text editor, and many more. So this is the example for executing the thread. That is, tabs of a web browser, text editor, and many more. Each thread belongs to exactly one process and no thread can exist outside a process. Okay, so each thread will belong to exactly one process and no thread can exist outside a process. Each thread will represent a separate flow of control. Threads have been successfully used in implementing a web service. They are also provide a suitable foundation of parallel execution of application in memory multiprocessor. Okay, so parallelly we are executing the threads in particular process. So in process is created and particular process, so many multiple threads are available. It will be executed parallelly in system. And this diagram represent the single thread and multi-thread. Okay, so diagram shows a register counter in a stack. System register, it will have a data and files code. Single thread, the process P, single process with P, single thread. So this is a single thread process. So one thread is executed in the system register. So in second diagram, single process, three threads. Parallelly, the process is divided into three threads and the three threads are executing parallelly to achieve or complete the process execution. So it will have a data files and the code is divided into three parts, that is three threads. Single part of execution is a thread. So three parts of execution, three part of the process is executed here. Okay, so this depicts the multi-threading process. This is a single threading, this is a multi-threading process depicted. Why do we need threads? Why we are going for a threads concept in the operating system? Threads are needed in OS for various reasons mentioned below. First one is responsiveness. It allows application to be responsive to user input. That is, other thread can react to user action if one thread is busy. So we are going for multi-threading process here. So if one thread is busy, other thread can react to user input. That is the responsiveness. This is the first reason we are going for. We are going or we need threads. And resource sharing. Second one is resource sharing. Due to memory and resource sharing, there is efficient communication without inter-process communication. This is the second reason. And next one is cost efficient. To create and manage threads, it requires less resources and time compared to creating separate process. For every process, we need a memory space. And also it will be more cost efficient. We have to manage the threads. So in single process, multi-threading concept is here. So it will be more cost efficient. Next one is parallelism. The threads implement parallelism on multi-core and multi-processor systems. It also improves the performance. So it will improve the performance of the CPU. The CPU won't be idle for a long time. The multi-threading process will actively keeps the CPU busy. Next reason is better CPU utilization. When one thread is blocked for IO operation, other threads can execute, other thread can continue execution. It helps in maximizing CPU usage. Next reason is simplified program design. Thread divides the bigger task into smaller tasks. It makes code easier to maintain. Okay, these are all the reason why we need threads. Next, we are going to see about the components of thread. The key component of a thread are mentioned below. Thread ID, it represents a unique identifier for each thread to differentiate one thread from other. So the thread will have an ID. Each thread will have a unique ID, so it differentiate from other thread. The operating system uses this ID to track and manage the threads. Next one is the program counter. It is a register that holds the address of a next instruction that will be executed by the thread. So the program counter, it's nothing but counter is nothing but a register. It will have the address of the next instruction to be executed by the thread. Each thread will have a program counter here. Okay, next one is register set. Register set is a collection of register that holds the current working variables and temporary data for the thread. That is, it will hold the current working variables and temporary data for the threads. Each thread maintain its own set of register values. Every thread will have a own set of register value. Next one the component is stack. It store local variable, function parameters, and return address for the thread. Each thread has its own stack. The stack of the thread maintains execution history, function called sequence, and prevents inference with other thread. So every thread will have a program counter, register set, ID, and stack. Everything it will have. Okay. These are all the components of the thread. Next, the type of threads. Already we said single thread, multi-level thread, like that. So in the operating system, it divided into two spaces, user space and kernel space. Based on these two space, threads can be classified into, yeah, sorry, user level threads, kernel level threads. User level threads are implemented in user space by the thread libraries. In this, the kernel is not aware of ULTs. That is, the kernel is not aware of the user level threads. Kernel manages them just like a single threaded process. In this space, operation like thread creation, scheduling, synchronization is done. So in user level thread, the operation like creation, scheduling, and synchronization will be done. Next, kernel level threads. The kernel of operating system directly manages kernel level threads. The kernel maintains thread information and also performance operation like thread creation, scheduling, and management. In this space, kernel is aware of all the threads in the system, unlike ULTs. So ULT will not know the kernel level threads, but kernel level threads will know all the user level threads. So every threads will have all the information. User level threads will have the thread creation, operation performance, like thread creation, scheduling, synchronization will be done. And kernel level threads will have all the operations like scheduling, creation, and management. And these are the types of thread. And thread operation, you also perform various operation in the thread that is mentioned below here. One is thread creation. You can create a new thread within your process. The new thread will have its own program counter, register state, and stack space. It will also share the code, data, files with other thread in the same process. Next one is a thread termination. Next operation is thread termination. It occurs either when a thread completes its execution or is manually terminated. When a thread is terminated, then all its resources are deallocated. Next, thread join. In this operation, one thread waits for another thread to complete its execution. So three type of operations here. One is thread creation, another one is thread termination, another one is thread join. Okay. So next one is difference between the process and the thread. Here, the difference between a process and thread is given in the tabular column. For first process, first point, the process means any program is in execution. Thread means a segment of a process. Process means any program in execution. The thread means particular part of a process. Next, second point is process takes more time to terminate. Thread takes less time to terminate since it will have a short lifetime. So many threads in each process, there will be so many threads here. So the thread will take less time to terminate. It takes more time for creation. Thread will take less time for creation. It also take more time for context switching, but thread will take less time for context switching. Here, the process is less efficient in terms of communication. Thread is more efficient in terms of communication. Multiprogramming holds the concept of multiprocess. Here we don't need a multiprogram in action for multiple threads because a single process consists of multiple threads. So we don't need a multiprocessor, multiprogramming here. Single process will have so many threads. It's already said. Here the process is isolated. Here the thread shares the memory. Each process will have a separate memory. Each process will have a separate address space in the main memory and it will start execution in the CPU. But in the thread will have share the same memory space for a particular process. So these are the difference between process and the thread. Okay. Next one is advantages of threads and disadvantages of threads. So here the advantages of thread is key advantages are thread context switching is faster than process context switching. Use of threads provide concurrency within a process. Efficient communication due to shared memory and resources. It is more economical to create and context switch threads. Okay, that is more economical to create and context switch threads. Efficient communication due to shared memory and resources. Thread allow utilization of multiprocessor architecture to a great scale and efficiency. So in spite of process, thread will have a greater advantage. The context switching is very faster. It provides concurrency within the process. It is more economical to context switch and efficient communication will be there, and there will be utilization of multiprocessor architecture to great scale. So these are all the advantages of a thread. Next, disadvantages of thread here. Threads have many advantages as discussed below and also some disadvantages too. Memory overhead for stack space and CPU time overhead for context switching. So every process will have multiple threads, so it will take so many time and so many memory space for context switching. So every time it will overhead for the CPU. May create inconsistency since they share same memory space. Next one is increased programming complexity. So every process will have so many threads. So for each thread, we have to share the resources like memory space and we have to execute each thread and it will have a stack counter that is variable and space, memory space to execute. So we have a programming complexity here. Since thread have access of each other's data, it increases security risk also. So every thread will have a access to another thread data that is inside the same process. There will be multiple threads. So each thread will have a accessing others thread data. So it will be increasing the security risk. These are all the disadvantage of the threads here. So we have seen the thread creation process and thread components and advantages and disadvantages of threads here. So that's all about this lecture. So in this lecture, we have clearly seen the process state, process creation, that is everything we have seen, process state and also thread creation, thread termination, and also the advantage and disadvantage of thread process, that is thread components and comparison between the process and the thread here. Hope you all understand this video lecture, and if any queries, kindly contact me through mail or a YouTube channel. So we can see the next topic in another video. Thank you. Thank you.